Assalamualaikum warahmatullahi wabarakatuh. Hi guys, we are from group 1 and we will show a linear regression tutorial using eviews and their analysis. This time, the material we will discuss is an analysis of the effect of change in money supply, interest rate, and exchange rate on inflation. Now, let's begin the tutorial. Let's start the tutorial with this eviews. Please open your eviews application. We currently use version 9, but for those who are using version 7 or 8 will not be a problem because in principle the analysis method used is the same. After you open the application, click on create a new eviews work file. After you click on it, then you can see there are structure type and date specification. As structure type, we use dated regular frequency, and date specification we use monthly because our data was monthly. And then you can type your start date, which is the earliest year in your data, and your end date, which is your latest year. After that, you can name your file, but it is optional step, so you can pass it, but I will name the file this time. After that, you can click OK. After that, will appear a work area. In work area, you can process the data with the tools inside. In work area 2, the data will appear after it imported from other database. For example, we import our data from Excel. Now, how to import the data? First, you can click File and then click Import and choose Import from File. Make sure you imported the data correctly. After that, you can click Next, Next, and after you make sure all the data imported is correct, like inflation, money supply, interest rate, and exchange rate, you can click Finish. After you make sure all the data is in work file, like exchange rate, inflation, interest rate, and money supply, the next step is test linear regression with eviews. We immediately carry out operation to produce a linear regression test process with eviews by clicking on the menu and click on Quick and choose Estimate Equations. After that, a window will appear. After a window appear, you can write the code in that window. After that, you choose the method. Please select LS or least square. This means you choose to use the all LS method and then click OK. If your steps are correct, then the new window that opens in eviews will look like this. There's coefficient, standard error, t-statistic, probability. Then we will test the classical assumption. The first is the test for normality. Keep in mind that the assumption of normality in OLS linear regression is the residual, not the variable. The normality test method with eviews is, please click on the view and then choose histogram normality test button. Then the results are as follows. The indicator is that when the probability value is above the standard value of 0.5, then the data is normally distributed. Conversely, if the probability value is below the standard value of 0.05, then the data is not normally distributed. From this test, the probability value is 0.680609, which means that this data is normally distributed. After that, if you want to see the output estimation of this equation, you can see it by click on views and then choose estimation output. The results are as follows. After that, we move to the second test. The second test is the multicollinearity test. Multicollinearity test assesses whether there is a correlation or intercorrelation between independent variables in the regression model. How to test multicollinearity with eviews is click on quick, then choose group statistic, and then you choose correlation. After that, there will appear series list. In series list, you type the formula. Then type money supply, interest rate, and exchange rate. After that, click OK. And the results are as follows. If the value is above 0.8, there is a multicollinearity problem. In this result, it appears that there are no values exceeding 0.8, which means that there is no multicollinearity in this data. After that, we move to the next step. The next step is the third, which is autocorrelation test. Autocorrelation arises because observations that appear sequentially over time are related to one another. This problem often arises when we use time series data. Many of these test methods can be done, but with eviews, we use the Bruce-Couvrey serial correlation LM test. The trick is on the menu, press the View button, choose Residual Diagnostic, and then choose Serial Correlation LM Test. Choose the legs to include. After that, click OK. The results are as follows. In this data, you can see by the value of prob chi-square. If the probability chi-square is more than 0.05, so that means there is no autocorrelation problem. But if the value of probability chi-square is less than 0.05, so that means there is an autocorrelation problem. In this data, the value of probability chi-square is 0.0102. Then it says that there is an autocorrelation problem in this data. How to improve the autocorrelation can be done by changing the linear model into logarithmic model or in percent form. After that, we move to the last step. The last step is heteroskedasticity test. Heteroskedasticity test with eviews is very easy. That is, please press on views and then choose residual diagnostic and then choose heteroskedasticity test. Then the selection windows will appear for the type of heteroskedasticity test to be used, which include Brev-Pagan-Godfrey test, Harvey, Glaser, ARCH, and White test. This time we use White. And then click OK, and the results are as follows. To find out whether there is a heteroskedasticity or not, you can see the value of probability chi-square. If the value of probability chi-square is more than 0.05, so that means there is no heteroskedasticity problem. But if the value of probability chi-square is less than 0.05, then there is a heteroskedasticity problem. In this data, the probability chi-square shows the value of 0.6133. Then, that means there is no heteroskedasticity in this data. And that's all how we explain one by one and in detail how to do a linear regression test with eviews along with the classical assumption test. Hopefully, this will helpful to you all. And for the last, thank you for listening. Wassalamualaikum warahmatullahi wabarakatuh.